Creating a matrix is just a generalization of creating row and column vectors. The values within a row are separated by either spaces or commas, and the different rows are separated by semicolons. Values of the rows can also be specified using the iterators. Think colon, linspace, etc. There must always be the same number of values in each row. If you attempt to create a matrix in which there are different number of values in the rows, the result will be an error message. Matlab also has several functions that create special matrices. For example, the zeros function creates a matrix of all zeros. You can pass either one argument or two. If you pass 1, you get a square matrix. If you pass 2, you get a rectangular matrix. As you can see, the first argument specifies the number of rows and the second the number of columns. Similarly, you can also create a matrix of all ones using the function ones. The function I gives you an identity matrix of the specified dimension. An identity matrix is a diagonal matrix of all ones. Rand gives you a matrix of random numbers. And as you can see, all the random numbers are IID uniform from 0, 1. You can also create matrices from existing matrices just as you had concatenated vectors. Notice how the first row of matrices are separated by the second row of matrices using a semicolon. You can also form a matrix by tiling another matrix, and the function to use is repmat. Let's say we want to tile the identity matrix, a 2 by 2 identity matrix, one below the other. You can create a diagonal matrix by specifying the diagonal vector using the function diag. Let's say I want to create a diagonal matrix of 1, 2, and 3. These are just a sample of functions, and Matlab has many more functions to create special matrices. Now that we've seen how to create matrices, let's go ahead and see how we could refer to the elements. First, let's create a matrix. Notice how the elements of my matrix A are the row number followed by the column number. We can refer to the element corresponding to the second row and the third column by giving the row number and column number to the matrix name. We can also access an entire column or an entire row using the colon operator. For example, in order to access the entire second row, I do this. I can also access an entire column. Note that using a colon for the column index means all the columns regardless of how many, and using a colon for row means all the rows. It is also possible to refer to a subset of matrix. For example, gives us a block of our matrix.